Okay, this is question number 11. An archer shoots an arrow. The height, h meters of the arrow above the ground, is modelled by the formula h equals 1.8 plus 0.4d minus 0.002d squared, where d is greater than or equal to 0, where d is the horizontal distance of the arrow from the archer, measured in meters. Given that the arrow travels in a vertical plane until it hits the ground, part A, find the horizontal distance travelled by the arrow, as given by the model. Okay. So, let's give myself a bit of room here. Question 11. So, basically, for part A, we want to solve that resulting quadratic. So, if I remember, this h is 1.8. If my pen wants to work, it's 1.8 plus 0.4d minus 0.0. Is it 0.0? Yeah, 0.02d squared. Okay. Now, I want to put that equal to 0 because I want to solve this quadratic. Okay. Solving the quadratic is basically going to give you a value for d, so I'm going to hop to my calculator. Just give me 2 seconds. Okay, Casio ClassWiz FX991EX, of course. And you're going to go to menu, option A for equation and function, polynomial, degree 2. We've got the 0. Or minus, shall I say, 0.002 as the x. Then we've got the 0.4 and the 1.8. Okay. And that is, if I bring the pen up, 204.4 meters to 1 decimal place. Okay. That's part A. Also, I would note that D cannot be the minus 4.4 meters due to D being greater than or equal to 0. Okay, I'd state that as well just to make sure. Okay, let's look at part B. With reference to the model, interpret the significance of the constant 1.8 in the formula. Now, the 1.8 is the height the arrow is fired from. Above the ground. Okay, that's part B. Part C. Write 1.8 plus 0.4d minus 0.02d squared in the form a minus b, lots of d minus c squared, where a, b, and c are constants to be found. Now, luckily, if you're still on your menu where the calculator was for part A, you get that the maximum x is 100 and the y is 109 over 5. This is useful as it's going to help us write it in this form that it wants us in for this question. So for part C, now that 109 over 5 is 21.8. So it's 21.8 minus your 0.002, lots of d, take away that maximum value, because don't forget it's completed the square form we want, and that was the maximum, which was x is 100. Okay, squared. Because if you expand that out, funnily enough, you get back to this that it wants. Well, not that one, but It was this one wants it up here, but it wants it in. Okay. That's all I'd write, and I'll also say that A is 21.8. I'd say that B is the minus 0.002, and I'd say the C is 100 as well. Okay, that is part C. Part D. It is decided that the model should be adapted for a different archer. The adapted formula for this archer is h equals 2.1 plus 0.4d minus 0.002d squared, where d is greater than or equal to 0. Hence, or otherwise, find for the adapted model the maximum height of the arrow above the ground. So that's d part 1, di, d1. Basically want to solve this, don't we? It's the maximum height that we want, don't we? We want it when d is 100, in a sense. So you're going to do 2.1 plus 0.4 times 100, take away 0.002 times 100 squared, which, funnily enough, is 22.1 meters when d is 100, because that's the maximum it could possibly be. Okay, it cannot be any higher than that, because from our completed squared form for part C, it kind of helps us to do part D, part 1, and especially part 2 as well. So for D part 2, the horizontal distance from the archer of the arrow when it's fired at its maximum height. So I've kind of given this away in part 1. When it's fired at its maximum height, its horizontal distance is 100 meters. That's kind of implied from part 1 as such for part 2. Okay, because that's the horizontal distance at the maximum height. But the maximum height was 22.1 when d is 100. So the horizontal distance must be 22.1, so the distance was 100. It's basically this in here. That's all I wanted for that one. Okay, that is how we can get all of the 9 marks for question number 11 as a modelling quadratic question.